Hello, Algebra 2 students. This is the video for example 4 for section 1.5. We're going to use graphing technology to solve equations still. Let's see what we have. Use graphing technology to approximate the solutions for the equation negative x squared plus 8x minus 13 equals the absolute value of x minus 4 to the nearest tenth. Let's see what we have. They want to teach us the intersect function. Now, they're not really showing you how you could use that on the graphing calculator. So let me show you with my graphing calculator. Okay, and then I'm going to show you with the Desmos. Actually, the next problem uses the Desmos. So with the graphing calculator, I've typed in the first equation, and you might not know where the absolute value function is. So under math, I forget what choice it is. One of these is absolute value. Maybe it's under number. Yes, under number. So under math, then number, absolute value. So now I have the absolute value of, and I need x minus 4, x minus 4. So now, whoops, x minus 4. There, let me make sure I have those correct. X squared, negative x squared plus 8x minus 13. It's always good to double check to make sure you have the, otherwise you're going to waste time. Let me see if I have the graph, or let me just do the standard zoom 6. See what that looks like. The first equation is the first one I graphed, or I typed in, which was the quadratic, and then we have the absolute value. Now, to calculate the, well, let me zoom in. Let me do a zoom box. Move my cursor up to here and down to here, so I can see the two intersection points a little bit more clearly. Don't have to, but it's going to help me with my old eyes to do that. So now it's zoomed in. I can see the two intersection points easier. I suppose you could use the trace function, but that's not that greatest. I have to zoom, I get this over here. I mean, it could be good enough. Somewhere in between, I'm looking at the x values, 2.63 and 2.77, somewhere in there is where that one intersection point is. But the graphing calculator it can calculate an intersection. Calculate. Second, calculate an intersection, that's choice 5. And it wants you to pick the two equations. Well, I'm going to pick the quadratic right there. It's on the quadratic, or here you can see it's y1, so it's on the quadratic. Enter, because sometimes you might have 3 equations, but here I'm only going to have 2, so it's going to start with y1, and then it's going to go to y2. So those are the two that I want it to intersect. Now it might ask me, it's asking me to guess. Well, if I push enter right now, it's going to give me this intersection. There are 2, and you have to know how many there are. It's not going to tell you how many there are. Here's the intersection at 2.697. That's the x value for that, 2.697. So it calculated it. I didn't have to zoom in or whatnot. And then to find the other one, I will have to go back out and calculate intersection again. Choice 5. This time, it's still the same 2 equations, but unless I move the cursor over, it's going to give me the same answer that I already had. I want to find an answer over here. So I hit enter, and now it's going to show me this intersection is at 5.3. Okay, that's with the graphing calculator. Notice these numbers here are similar to what they have here, but they didn't show you how to do that. So hopefully that helps you understand how to calculate intersection using a graphing calculator. Then this problem here, they have the Desmos. So let me show you how to do it with Desmos. It's a different equation, so I need to type in the 2 equations, if you don't mind. Just a little bit. Y equals x squared plus 2x minus 1, and y equals absolute value of x plus 2, and then outside the absolute value bars is a plus 2. Let me double check. X squared plus 2x minus 1, yes. Absolute value of x plus 2 plus 2. This is to the nearest tenth, and I believe Desmos has it go to the nearest tenth. If you need to be more accurate, you might have to go with the graphing calculator. But see how they've already identified, like this point right here is the y-intercept for that graph. They didn't highlight the two x-intercepts here, but they do have dots right there. I'm trying not to hit it at the intersection. So they intersect at negative 3.303, and they intersect up here at 1.791. Memorize those two numbers. 1.791. Oh, they said to the nearest tenth. Okay. So 1.8 and negative 3.3. 1.8, 1.8 and negative 3.3. So that's how you can use it with Desmos. And it actually went more than the tenth, didn't it? So that's good. That's it. That's how you can use technology using the intersect function on your graphing calculator or on Desmos. Your teacher may assign some of the following: 26 through 29, 6 and 31. That's it for this video. Have a great day.